Friends, a massive landslide was triggered over Dharali and Harsil villages in Uttarkhand district, Uttrakhand on August 5, 2025. The sudden flash flood swept away homes, buildings, bridges, restaurants, roads, and claimed several lives. In this tutorial, we will carry out a comparative analysis of satellite images before and after the event to reveal the extent and severity. Now log into Copernicus browser and download the bands of Sentinel-2 for before and after dates. Open QGIS and load raster band for your satellite imagery into the layers panel. I am making true color images of pre and post event in ArcGIS Pro for visualization. For this, open ArcGIS Pro, go to Geoprocessing, select Composite Bands, use 432 in sequence. The comparison of these two images shows changes in surface indicating a landslide has happened there. Landslides often remove vegetation, which the NDVI index detects by highlighting areas with low vegetation coverage. So, we are calculating this index in QGIS. For NDVI, you'll use the infrared edge band 8 and red is band 4. Navigate to processing raster calculator. Under the expression box, enter the formula band 8 minus band 4 divided by band 8 plus band 4 in brackets. Under output layer, click the browser button to name your new file and save it to your desired folder. Ensure the current layer CRS is matching, then click OK to process. Similarly, calculate NDVI for after dates. Right click the newly created NDVI layer in the layers panel and select properties. Go to symbology, change the render type from single band gray to single band pseudo color. Select a suitable color ramp, red, yellow, green. Click classify and then apply. NDVI values range from -1 to +1. Healthy vegetation typically yields 0.4 to 0.8, bare soil closer to 0, and water result in negative values in red colors as is showing in this raster. River water in red colors. After visualization and comparison, we find the affected area is showing loss of vegetation. Now we will calculate an other index called bare soil index BSI because landslides often remove vegetation and exposes soil, which the BSI detects by highlighting areas with low vegetation coverage and high soil brightness. Most of the pixels related to landslides present high BSI values more than 0.7 with high reflectivity in B11 and with little presence of vegetation and NDVI. The script for landslide detection for rapid mapping is based on the response of the BSI index for the detection of traces of the soil movement. The result allows us to extract the shape of the landslides in the terrain and to calculate their direction of movement. Now, in QGIS, go to Processing, open raster calculator and type the expression band 11 plus band 4 in brackets minus band 8 plus band 2 in brackets divided by band 11 plus band 4 in brackets plus band 8 plus band 2 in brackets. Here we'll use band 11, band 4, band 8 and band 2. We'll reproject band 11 to match resolution to 10 meter. Now we are calculating differential BSI using the expression BSI post minus BSI pre, which is very effective in landslide modeling, particularly for rapid mapping and detecting surface disturbances. I am changing low index value color to lighter one to give contrast to the raster. Now the resulting raster explicitly identifies recent traces of the soil movement and extracts the shape of landslides. Comparing pre and post event imagery significantly improves visualization to distinguish landslides from existing backgrounds. Friends, That is all in this tutorial. Keep on watching me and don't forget to like and subscribe.